Level 3, I can find the solutions to the system of linear inequalities using elimination after multiplying both of the equations by some number. So in level 2s, we only had to multiply one of the equations. Level 3, you're going to have to multiply both of the equations by something to get a variable to cancel out. You can pick either variable to cancel out. For A, I'm going to go ahead and pick X to cancel out. You could have picked Y to cancel out. It doesn't matter, but you'll just multiply by something different in order to get those variables to cancel out. So I'll take you through on how to do A by eliminating the X's, and then I'll take you through eliminating the Y's and show you that you'll get the same answer, but you're just the process is just a little bit different because you're multiplying by something different. So if I look at A, what I want to do with that first one is I want to multiply the top one by 5 and the bottom one by 3. What this does is if I'm eliminating the X's, if I multiply the first one by 5, I'm going to get 15x, and the bottom one, I'll also get 15x. So very similar to finding a common denominator of a fraction, it's exactly what you want to do here. You basically want to find a common number that these two equations have with those variables. Okay, but I want to make one positive and obviously one negative, so when I add them together, they're equal 0. So again, it doesn't matter which one you pick. You just got to pick one of them. So I'm going to pick the bottom one. So I'm going to multiply this 5 to everything. So I'll have 5x plus 20y equals negative 10. And then I've got negative 15x plus 9y equals a positive 39. So now you see if I add these two equations together, the 15x minus 15x is 0. And then I'll have 20y plus 9y is 29y. And negative 10 plus 39 is 29. So y is going to equal 1. And now just like before in level 2s, it doesn't matter which equation you substitute y equals 1 in for. You could do the first one, you could do the second one, you can do the ones that you multiplied by. It doesn't matter. I'll pick the first one again just to keep it consistent. So 3x plus 4 times 1 equals negative 2, and I'll go ahead and solve for x. So 3x plus 4 equals negative 2. Subtracting 4 from both sides, I'll get 3x equals negative 6. And then dividing both sides, I'll get x equals negative 2. So those are your two answers, negative 2 and 1. Same thing that you would do is if you wanted to eliminate the y's. So I'll take you through that. If you don't care to know how to do that or show it in the same way, go ahead and fast forward this. So the first equation was 3x plus 4y equals negative 2. And 5x minus 3y equals negative 13. Okay, so if I wanted to eliminate the y's, okay, 3 and 4, so I'd multiply the first one by 3 and the second one by 4. For this one, you don't have to pick one that's going to be negative, because if you notice, the 3y on the bottom is already negative, so I don't have to change anything. So I'm going to go ahead and multiply this 3 inside here, so I'll have 9x plus 12y equals negative 6. Not negative 6. Yeah, negative 6. And then 20x minus 12y equals negative 22. Just kidding, negative 52. I can add or multiply. So this is negative 52. Sorry. Okay, so now that you see we've got our y's, we can cancel out, and then we'll add 20 plus 9 to get 29. This will equal negative 58. And then you divide by 29, so x will equal, again, negative 2, which is what we got in the beginning. And if you substitute that in, I guarantee you, you will get the same y value of 1. Okay, so again, it doesn't matter which variable you choose to eliminate. Just pick one and go for it. Multiply one by one number and the other by the other number, and make sure that one is positive and one is negative. Okay, let's look at B. If you notice, B looks a little bit different because the x's and y's are on different sides of the equal sign. So I'm going to go ahead and change that. In the first one, I'm going to subtract the 4y to get it on the same side as the x. So I've got 2x minus 4y equals 6 for the first one. And then for the second one, I'm going to go ahead and move the 9 over to the other side. So I have 3x equals 6y plus 9. And then I'm going to subtract the 6y to get it on the same side as the other x. Okay, so again, I'm just doing all of this work of moving things around in order to get the x's and y's on the same side of the equal sign. Okay, so here we go. We got to eliminate a variable. I'm going to pick the x's. You could definitely pick the y's, but I'm going to go ahead and pick the x's to eliminate. So I'm going to multiply the first one by a 3 and the second one by a 2. Since the original numbers by the x's were both positive, I need to pick one of them to be negative. So I'll pick the first one to be negative. So now I'm going to distribute this 3 to everything inside. So I'm going to get negative 6x plus 12y equals negative 18. And then I'll have 6x minus 12y equals positive 18. So now if I add them together, this is going to be 0, and my y's are going to be 0, and my 18 is 0. So I get 0 equals 0. Your answer is not 0, as many of you might think. Since this is a true statement, 0 equals 0, the answer is infinitely many solutions. What this means is that any x value and any y value will make this equation true. So there's a bunch of different answers that you could put for this. So we can just write this as infinitely many solutions. And the last thing that we have to remember to do is for each problem, write it as an ordered pair. So the first one would be negative 2, 1. The second one doesn't have an ordered pair, so we'll just leave it as infinite many solutions. Or you could, if you want to abbreviate, you can write IMS. That's fine too. But know that when you get a true statement, 0 equals 0, 12 equals 12, 1 equals 1, something that's equal on both sides, your answer is infinitely many solutions. When you get something that is not that, when like 0 equals 4 or 2 equals negative 3, obviously those are not true, so this one would be a no solution.